So I'm going to talk about some of the programs that we have running here all across the Thames Valley at the moment, but also some perspectives, I hope, on some broader issues. So, as you know, the Oxford Vaccine Group is about 100 people working in a whole variety of different areas of research, from clinical trials, which many of the nurses in the group are involved in, and the research fellows, to laboratory studies, both in the design and development of new vaccines, and also the evaluation of vaccines that are currently either in the trials or in the schedule. But we also have quite a lot of activities outside of the UK, and I want to touch on some of those in this presentation and give you some context. Now, when you look at how things have developed over the last few centuries, we've actually got quite a lot of vaccines now. This is Gary Nable's chart from the New England Journal from a couple of years ago, just showing how many vaccines have been developed, and with a particular concentration of new vaccines appearing over the last 3 or 4 decades. And of course now many of these are available, and quite a large number are now in use widely around the world. And it's thus quite striking that still today the majority of the deaths in children under 5 years of age are from infectious diseases which are potentially vaccine preventable. And you can see here on this slide that perhaps the most important of those is pneumonia. Even in the neonatal period, where lots of the deaths are actually from congenital abnormalities and so on, infections still make up a very substantial proportion of the causes of death in this age group, and has really been identified by the World Health Organization as a major priority to try and reduce early life deaths. And I'll come on to a little bit of that in a moment. But although there is still this huge burden around the world of infectious deaths caused by diseases which we could prevent with vaccines, we have come a long way. This is 1980 here, which was just when I was doing my A-levels, and you can see at that point only 20% of the world's children were getting vaccinated. It doesn't, well, looking around, doesn't feel that long ago to many of you, but it certainly doesn't feel that long ago to me. But now we're, depending on where you are, we're up to 90%. And even in the poorest regions of the world, still almost 80% of children are being vaccinated. And of course, what this picture hides is that these pockets where there's no one vaccinated, we've got, even in countries that have quite good overall coverage, there are pockets where no one at all in the communities are vaccinated. And that's particularly a problem across parts of sub-Saharan Africa, but also in Switzerland, as it turns out. Perhaps the most important of all of the things that we can prevent through vaccination that will affect mortality in the under 5s is pneumonia. And this is the distribution of pneumonia deaths in the world. You can see the highest proportion of deaths in India and other parts of South Asia, but also a large number in the huge sub-Saharan African region. And for this reason, we've been particularly interested in the prevention of pneumococcal disease here at OVG over a very long period of time now. And just to first of all make a very brief comment about a project which Matthew Snape, who's here, is leading, and you'll hear from him later on today. But this is a study looking at different schedules. So if you were to go to the US, the pneumococcal vaccine, so that's in this country we use Prevnar 13, is given at 2, 4, 6 and 12 months of age. Here in the UK and a number of other countries, we give it at 2, 4 and 12 months of age. And the reason why we have these early doses is because there was a lot of disease in the first year of life. And so if you want to start to get control of pneumococcal disease, you need to make sure those babies are protected. This booster dose here was really in the original schedules to try to also stop the disease in the first few years of life after infancy, and to give a boost right up to school age, where actually the rates of serious disease from pneumococcus start to fall very rapidly. But now what we've realised is that with either of these two schedules, you prevent carriage of pneumococcus in the nasopharynx. and therefore no one is really at risk from the types of pneumococcus that are in the vaccine. And so if you can maintain very high levels of antibody after that 12-month dose, it means all of us are protected against those types. And then you don't need to have these lots of early doses in order to prevent disease, because those bugs are no longer circulating. And so this is a really important project, saying, well, what if we dropped from those 2 doses to just having 1 dose in this early period and then the booster at 12 months? Could we still maintain high levels of antibody which stop carriage and therefore transmission of pneumococcus? And that's clearly important for the UK, but even more important for the developing world. And the reason for that is at the moment, if you're in a very poor country, the Global Alliance of Vaccines and Immunisation will pay for your pneumococcal vaccines. And in fact, it doesn't matter which of the schedules you have because someone else is paying. But over the next 5 years, many of those poor countries will graduate from Gavi, which means that their GDP reaches a level where Gavi will no longer support their vaccine programs. And at that point, many countries will start to struggle to be able to provide pneumococcal vaccine. And so looking at schedules which are cheaper and use fewer doses starts to become very important just for the maintenance in those countries of being able to provide vaccine. And just to give you an idea, there's one West African country where their total budget for all of the vaccines they give is only $60,000 a year, because all the rest is paid for by Gavi. But in a few years' time, when they graduate, that $60,000 a year, the Health Ministry then has to pay a couple of $1 million a year. And although that doesn't sound very much in a big economy, where there's huge scrutiny on how money is spent, to suddenly find a few $1 million from a small health budget is very difficult. So that just gives you an idea about these countries which start to graduate from Gavi and will have a problem. This slide's out of date, and it's a lot more than 37 enrolled now, but this is all across the Thames Valley. And this is a project that's funded by the Gates Foundation and the Department of Health. Now, a lot of our work over the last 12 years now has been in Nepal, in South Asia, working at this hospital. And we've been looking at invasive bacterial infections, and particularly with a focus on pneumonia, which is the leading cause of death in that country in young children. Incredibly, excuse me, 60% of the admissions in children under 5 years of age have meningitis. And what you can't see, because I've covered it up by the picture, is or pneumonia, which is a critical bit. And the largest proportion of those is caused by pneumococcus. So a pneumococcal vaccine here is likely to have a big impact on disease. And what's striking there, which is quite different from Europe, is that disease is dominated by just one type of pneumococcus. So these are a large number of types across here. You'll know that although there's 13 in the vaccine we use in primary care here, there's actually 90 different types of pneumococcus, and all of those in theory can cause disease. Oh dear, I don't think we want to restart at the moment. But we'll get a reminder in 10 minutes. Dominated by one type, serotype 1, which was the first pneumococcus to be typed, which is why it's called serotype 1. And the reason for that is it caused outbreaks in developed countries, periods where there is lots of disease caused by this serotype, and then it just disappears for a few decades and it comes back again. But in the developing world, it's been a dominant cause of pneumonia and meningitis for a long period of time. And you can see here that's the case in Nepal, with serotype 1 being dominant, but also major contributions from serotype 5 and serotype 14. And both of the vaccines, as I mentioned, we use the vaccine that covers 13 types. There's another vaccine that covers 10 types, which in fact is the one that's now used in Nepal. And both of those will cover those important types. The other thing to note in that region in South Asia, and the same is true here as well, is it isn't the same types of pneumococcus that cause disease at all ages. And so you can see here, the coloured ones are the ones which are covered by pneumococcal vaccines. But there's a large number of infections in very young children that are completely different serotypes that will never be covered by the currently available vaccines. And I think this is particularly important in some developing countries where there are very, very high rates of exposure to these many different types. And so here you can see that well over half of, maybe 2/3 of the strains are not covered by the currently available vaccines in Nepal. So the first question that we've looked at over the last few years is, what about using a 2+1 schedule? And the reason why this is important is that most of the developing world of these amongst poor countries currently uses a 3+0 schedule. So they give the vaccine at 6 weeks, 10 weeks and 14 weeks, which, given the comments I've just made about the importance of a booster dose at a year of age to try and prevent carriage of pneumococcus, the schedule that WHO has recommended is actually not ideal for achieving that. And so we looked in this study at what happens to antibody levels at between 2 and 4 years of age if you use a UK-like schedule in South Asia, or the type of schedule that is currently recommended in most developing countries. And you can see, not surprisingly as you would predict, that you get, particularly against these key types 1 and 5, much higher antibody levels if you use the booster dose, and here it's given at 9 months of age rather than 12 months, but do a 2+1 schedule. And this is extremely important because this study led Nepal to introduce the 2+1 schedule, being the only Gavi-eligible, so very poor country in the world that uses this optimal schedule. And so this was a very important study in driving that change in practice. Now, of course, being the first country, Nepal, to use a 2+1 schedule, it's very important that that is properly assessed. And the Global Alliance for Vaccines and Immunisation has provided a very large grant for us to now start to evaluate that schedule to inform all of the other poor countries around the world about whether that would be a better programme. And it's a very complicated programme which includes carriage studies to see what happens to the rates of carriage of the different types of pneumococcus, through to looking at immune responses and looking at the economic evaluation. One of the things that we've observed is that some of these families, when they come into hospital with their child with pneumonia, they spend all their money on the x-rays and the antibiotic treatment, and they're then plunged into poverty afterwards because they've used up all of their income for that year in treating the child with pneumonia. Over the last year, we've been looking at carriage rates and find that in the preschool age group, sorry, this is the under 2s, in the urban areas, nearly 75% of children have pneumococci in their throats when we swab their throats. In the rural areas, it's nearer 85%. In very young babies under 2 months of age, there's a very low proportion who carry pneumococcus. And what this shows is, again, all the different types of pneumococcus here, and the first group here are the ones which should disappear now that the vaccine's introduced. But what was very interesting is that more than 20% of children had at least 2 different types of pneumococcus in their throat, which is very important. If you think about the way we evaluate vaccines using carriage, we usually only look the methods we use, we can usually identify one pneumococcus, but using the methods we used here, many of them have more than one. And the other thing to notice is that serotype 1, the major cause of disease, if you look in the throats of healthy children, you just don't find it. So these are the throats of healthy children here, and in fact, looking at several thousand children, we only found one serotype 1 in the throat. So it's very, very rarely carried, but it causes a lot of disease. But interestingly, when you look in the throats of children with pneumonia, you find a lot of serotype 1, which is this tall bar here. And so one of the things that we can do to look at the impact on serotype 1 is measure carriage of children with pneumonia after the vaccines has been introduced. And we'd expect to see it disappear from carriage in that group. I won't go into this in detail, but what this shows is the relationship between different types. So these are all those different types of pneumococcus, and the thick lines means that those types like living together. In other words, when we do a swab, they're there together in the throat. And this is absolutely fascinating because it means that some types of pneumococcus really never exist unless they're with one of their friends. I think that's really rather lovely. Now, this is just as a thank you slide to the many people involved in that project in Nepal. And this is last year with the first baby to be vaccinated in Nepal against pneumococcus. And over the next few years, we'll be looking at the impact of that program and the implications that has for many of the other countries in the region. Now, I want to very briefly next mention RSV, which you're going to hear more about later in the day in the debate. And the reason why I mention it is just because it's a very important cause of admission to hospital in infancy here in the UK. You can see we've actually had increasing rates of admission to hospital over the last few decades, which we can't fully explain, but probably changes in parents' expectations and community services, which have driven more people to come to hospital. And paediatricians are hopeless at keeping people out of hospital. If you come to hospital with bronchiolitis, you get admitted. And so we've seen more and more admissions. So we have a very large hospital burden, so it's a big problem. And over the winter, we also have our intensive care unit full of babies with bronchiolitis. But actually, when you take a global perspective, this is the second most important cause of death in the first year of life in the world. Malaria being the most important in the first year of life, but RSV being the second most important. And there's one other really interesting aspect to this, which we've recently we're in the process of trying to secure some funding from the European Commission to study this. And this is just a schema to try and explain what we're trying to do. So here's the mother. We know that the mother transfers some antibodies across the placenta to the baby, because babies who have lots of antibody get no RSV disease in the first few months of life and don't get admitted to hospital. But some of them do get bad disease and get admitted. We know from many studies over the last 50 years that if you've had this, it's more likely that you'll become a wheezy baby and possibly develop asthma. Now, what has not been clear is whether babies with rubbish lungs get RSV and get asthma, or whether RSV causes asthma. And clearly those are really important questions to address, because if that causes that, then preventing this could have this huge impact on the rates of wheezing in early childhood and potentially asthma. And there's some recent studies suggesting that if you use polivizumab, which is a monoclonal antibody which binds to the virus and neutralizes it, that's used for premature babies to try and stop them getting RSV disease. It's very expensive, which is why we don't use it for everyone. There's some recent studies suggesting that if you prevent this disease, you can reduce wheezing in the next few years of life. And so that everyone's a bit uncertain whether they can rely on the data at the moment, but it's incredibly exciting that there's the first chink of evidence that maybe a program that would stop this could have an impact further down the line against wheezing. There are no studies yet which have shown any impact on asthma, because you have to wait so long. The problem with asthma diagnosis, as I'm sure you know, in the first few years it's very difficult. Lots of wheezy children who never go on to develop asthma afterwards. Another 10 minutes has gone past. So the study that we're going to do is to have a look at, not at the interventions, because at the moment there are no licensed vaccines to do this, and there are no programs. There is a phase 3 trial going on around the world at the moment of giving a vaccine which is from a company called Novavax, but the program's funded by the Bill and Melinda Gates Foundation to give mothers a vaccine against RSV to try and increase the levels of antibody in their babies and prevent these early hospitalizations. And so that trial we think will report sometime next year, so that's extremely important. And I've mentioned this monoclonal antibody, which is already used for very high-risk babies. So what the study is that we hope will be funded later this year by the European Commission is to look at biomarkers, so things we can measure in the blood of babies that will predict who's going to get bad disease. And then of those who get bad disease, can we identify things in the blood which will say who's going to get these complications of wheezing or asthma. And that programme, unfortunately not all coming to Oxford, but it's about 11 million euros, and with it's a programme across the whole of Europe. And we'll be doing about a tenth of that project as it stands at the moment. But I think a very exciting project in an area which is of great importance for early child health. I also just want to very briefly mention pertussis, and I'm sure you'll all be aware that we had over the last few years a big upsurge in the amount of pertussis in the UK. And when you look back, this is just the picture from the Green Book, that once immunisation came in, there was pretty good control of pertussis, which before that had been causing a crazy number of cases that were being notified. There was a scare in the 70s about whether the vaccine was safe, and coverage went right down, and there was a big upswing in the number of cases. You can see this drop in coverage. And then as people became more reassured, we had very high vaccine uptake, and we have had a long period of time with relatively low numbers of cases and very low numbers of deaths and serious disease in young childhood, in early childhood. But we have continued to see some babies on intensive care with whooping cough. So this is not a vaccine which has resulted in the complete disappearance of whooping cough, unfortunately. And that's because it doesn't fully induce herd immunity from vaccination and prevent everyone from getting disease. But what we saw in the last 5 years has been this increase in the number of cases affecting particularly young children. And I think it's now pretty much accepted that the leading explanation for this was the switch from the wholesale pertussis vaccine, which we used up until the early 2000s, to the acellular pertussis vaccine, which we've been using since then. And the wholesale pertussis vaccine essentially was mashed up whole bacteria. It contained about 3,500 to 4,000 proteins, and it was quite reactogenic. So we saw many more babies than we do now who had a temperature or some other syndromes associated with the wholesale pertussis vaccine. And the acellular vaccine is much safer. There's many fewer vaccine reactions since we switched to the acellular pertussis vaccine. But the downside of the vaccine, it turns out that we've learnt over the last couple of decades in a number of countries that are using it, is that about 8 to 10 years after the acellular pertussis vaccine is introduced, in many countries there's been an increase in the number of pertussis cases. And we think the reason for that is because the duration of immunity from the acellular vaccine is shorter, so we don't protect children for as long after they've had their doses. And the second reason is perhaps because the acellular vaccine is less good at preventing transmission. And so the reason why I say that is there's some great studies which have been conducted by the FDA, which is the equivalent of the MHRA in the US, where they have put baboons in a cage and vaccinated them with one of the pertussis vaccines or the other. And only the wholesale vaccine seems to block transmission between these animals, whereas the acellular vaccine still allows transmission to happen even though they've been vaccinated. So they challenge them with pertussis to see whether one can transmit to the other. And so we think there's these two components. One is that the acellular vaccine is less good at blocking transmission, and the wholesale, and also it has a shorter duration of immunity. So there's now, in our population, there are different groups of people. There are the younger group who have only ever had the acellular pertussis vaccine. There's a group of children who are in the middle who got wholesale pertussis as infants and then got the acellular pertussis vaccine as a booster at preschool age. And then this group should now say wholesale. Then there's another group who are everyone over about 11 or 12 years of age who have only had wholesale pertussis vaccine. And one of the questions that we have is what is different about the immunity that's generated by these different schedules. And so part of this project, which Dominic Kelly, who's, I don't know if he's going to be here today or not, but he is going to be leading a study, again funded by the European Commission, to look at the immunity that's developed after Wholecell, a combination or a cellular vaccine, by using boosters of the acellular vaccine to look at how children's immunity is boosted differently with these different vaccines. And the second study, which is going to happen at 3 countries in Europe, including here in the Thames Valley, but also in West Africa, is a study actually going back and immunising babies either with the Wholecell vaccine, the old-fashioned vaccine, or the acellular vaccine, and using the modern tools that we have to study the immunity that's developed, to see whether we can understand what it is about this Wholecell vaccine which made it better, so that we can then feed that into the development cycle for new acellular vaccines, so new safe vaccines, which would actually give us better protection. And this study, I think, is a very exciting one and quite innovative. You might say, why would we go back to giving babies the Wholecell vaccine that was ditched in the UK more than 10 years ago because of concerns about it not being as safe as the acellular one? Well, the Wholecell vaccines are actually given to more children in the world than acellular vaccines, because the Wholecell vaccine is used in all developing countries. And in fact, developing countries were thinking of switching to the acellular vaccine so they could be more like us. But WHO have suggested that they don't switch because of these concerns about the acellular vaccine and that it doesn't induce such good immunity. So I think this is very important to go back and try and understand why this vaccine worked better. And we have such good tools now to be able to explore the immune response that we'll apply those to this program. So a very exciting program. Selena's going to talk to you about typhoid in a moment, and I wanted to very rapidly touch on some of the programs that we've been doing here. Selena will talk about the human challenge model that we've had running here over a number of years, which is where we deliberately infect people with typhoid, not just because it's fun, but so that we can seriously test new vaccines and whether they are likely to work. And there's some absolutely fascinating biology that emerges from these sorts of studies. This is looking at the genes which are switched on in the first day after the volunteers drink the bacteria. So these volunteers feel completely well at this stage. They've just drunk some bacteria, just like you would if you had some contaminated food that just had some bacteria. In fact, most of our food does have some bacteria on it, so it's but most of those are harmless. But when these volunteers drink it, they feel absolutely fine. But when we look in their blood at the genes which are being switched on, even in the first day, we can distinguish those who are going to go on and develop typhoid from those who don't. And we're now exploring what those genes are and what it is that happens in that first 24 hours that predicts what's then going to happen with them. We've done one study a few years ago evaluating a new typhoid vaccine which really didn't work. The vaccine, by giving a single dose of it, as it was an oral vaccine, it didn't prevent typhoid in our volunteers. And I think that was an important result to have to help inform further development of that vaccine. And Selena will talk about a very important study which is about a vaccine which is very likely to become the major vaccine that is deployed around the world where there are large numbers of cases. We're also going back and re-challenging people who have previously had typhoid. And the reason for that is to try and understand what happens in endemic settings where there's lots of disease. And we know that probably people eventually start to build up some immunity, and to try and understand what the mechanisms are for doing that, which will help inform both future vaccine design, but I think importantly how you might think about deploying the new vaccines in many of those developing country areas. Also in South Asia, paratyphoid has now emerged as a major problem, and we have a challenge model for paratyphoid as well. There are a number of vaccines in development, but none of them have been tested so far. And so with the paratyphoid challenge model, we're hoping to test the first of these new paratyphoid vaccines, possibly in 2018. So this isn't something that's going to happen immediately. And just to give you an idea of how important paratyphoid has become, half of the returning travellers who have enteric fever have paratyphoid and not typhoid now, whereas previously it was almost entirely typhoid. Now there's a huge exposure to paratyphoid, but no vaccine for that. So to finish up on this, we've worked with mathematical modellers who are working, trying to work out how typhoid is being transmitted in developing country settings, and therefore how we might deploy new vaccines when they become available. And this has revealed that there's a whole series of questions that need addressing before we adequately know how we might be able to deploy these vaccines. And so we have a very large team now in 3 countries, in Nepal, in Bangladesh and Malawi. And in those areas we're going to, over the next 5 years, be studying about 100,000 people in each country and following what happens when they develop typhoid and who they transmit it to. And this is, I think, a very exciting project which will provide the framework for how new typhoid vaccines will be introduced. It seems to me, and I'm sure you feel the same, that we've for such a long period had a very large number of quite negative images of vaccines. And it's interesting that over the last few years, things do seem to have changed a little bit. And although with this petition, which you'll all be aware of, I have to go and face the Health Petitions Committee next week about this. But it seems to me that apart from personally this being a bad thing, actually this is very good news for vaccines in general, that so many people can see the benefit and that they were prepared to go onto a government website and petition. And I think this is a great moment actually for vaccines where there is a recognition that they can have a huge impact on health. This is what our vaccine program looked like 20 years ago, and many of us will remember that. It looks a little bit flimsy 20 years ago, and it's actually changed rather a lot since then. And this reflects what all of you are doing in providing those vaccines to our population. And I suppose the question that you have to ask is, how much difference have we actually made by putting all that in? It's a lot of extra work in primary care. It creates a lot of difficulties in communication with families and so on. So does it actually make any difference? And the first thing I wanted to just draw on this last slide, Karen, is that actually from the 1990s to now, if you take even the crudest measure of whether we're doing anything, mortality is falling in young children in this country and all developed countries. Which is the line at the bottom. It's not just falling a bit. Since 1990, it's fallen hugely. And the new vaccines we've introduced over that period of time are part of that story. It's not the whole story, but it's an important part of that story. Perhaps even more importantly is over that period, that rollout of vaccines, particularly in sub-Saharan Africa, has had the most enormous impact with this falling line of the number of deaths that occur. And what is absolutely astonishing when you project this forward 20 years from now, we'd expect mortality to continue falling here, but perhaps even more exciting is by 2035 we would expect the mortality in developing countries to match where we are here if this trajectory continues. And I think that's incredibly exciting that we all have a part to play in that. The difficulty is that to make this line come down, you can't stand still. We need to continue the efforts that we all do in trying to improve health. And the bit that we can do, our job, is to do that through immunisation. And so I wanted to end just by thanking all of you for your part in making this happen.